Let's try to understand the contribution of J.J. Thomson, the, the British physicist in 1897, in determining the ratio of charge to mass of electron through by using a cathode ray tube. Before that, we have learned that uh, through experiments through cathode ray tube, established that there's something inside the metal of the electrodes which is fundamental to every atom and which might be present inside the atom and which are negatively charged, which means that the cathode rays or the cathode ray particles which is present in every electrode or every or no matter what the gas is there inside the cathode ray tube is gets emitted from the electrode. So which turns out to be that electrons are one of the fundamental particles, and that too a negatively charged fundamental particle present in all the matter. Here the matter we are considering is the electrode. So now what J.J. Thomson has done, is he has tried to find out, has measured not the charge on an electron, nor the mass of an electron, but he has measured the ratio of the charge on an electron to its mass to be 1.758 into 10 to the power 31 coulomb. This much coulomb of charge in 1 kg of electron. So he has measured the charge to mass ratio of the electron. So what he has done here, he has modified the cathode ray tube that were earlier used to detect the negatively charged particles called electrons, right? So what he has done is that this is the shape of the cathode ray tube. Here a he is still using two electrodes, the cathode and the anode, which is being connected to the battery of high voltage. The one which is connected to the negative part of the battery is known as cathode, and the electrode which is connected to the positive part of the battery or the high voltage system is anode. And what he has done is that he has made many holes in the anode so the cathode rays that emerges from the cathode, it gets through the anode, and he let it pass through a magnetic and electric field. For magnetic field, he uses a magnet with north and south pole, and in order to apply electric field, he has used plates so that the cathode rays which passes through the anode goes through the magnetic field as well as electric field. And what he has studied is how much the electrons or the cathode rays or the cathode ray particles deviate from their straight path. B is a straight path, and how do we, although electrons are not visible, in order to know that they are traveling through this cathode ray discharge tube, he has put a screen which is a fluorescent screen. So this special screen, what's a specialty about the screen is that whenever electrons strike the screen, it gets glow. It gets glowed. So what he has done is that when electric fields are applied, which is denoted by E, the electrons, instead of moving straight, they move upward towards the positively charged plate, which proves that the electrons that are emitted by the cathode or the cathode ray particles, cathode rays are negatively charged particles, and when when magnetic fields are turned on, when we place the magnet, when the cathode rays are allowed to pass to the magnetic field, what happens is that they deviate towards C. So A and C are the points when electric field or magnetic fields are applied, and there is a deviation of the cathode rays from their normal path, which is B. What Thomson has observed is that the amount of deviation of the cathode rays, or when electric field is applied or when magnetic field is applied, depends on three factors. The first factor is how much it will deviate. It depends on when electric field is applied. It depends on the charge on the electron, the quantity of charge that is present on the on electrons. And also more the charge on the electron, more will the deviation, either towards A or towards C when electric field or magnetic fields are applied respectively. And it also depends on the mass of the particle. The more the mass of the electron will be, no, the lesser the mass of the electron it will be, the deviation will be more. So the deviation is inversely proportional to the mass, and it is directly proportional to the quantity of the charge that is present on the electrons. And it also depends on the electric and the magnitude of the electric field denoted by E, and the magnetic field that you are applying, and the path of the cathode rays through which the cathode rays or the cathode ray particles are passing through, right? So he, by carefully measuring the amount of deviation when electric field or magnetic field is applied, J.J. Thomson, the British physicist, was in 1897 was able to measure the ratio of the mass, or ratio of the charge on the electrons to its mass, and it turned out to be 1.758 into 10 to the power 31 coulombs. This is charge, which is coulomb. A charge is measured in coulombs, and the mass measured in kg.